Hello, everyone. Welcome to Affordable Housing, the case for passive house design and net zero energy. This webinar is presented by Build Our Future. We are a collaboration of Alexandrians dedicated to supporting our transition to a zero carbon community through changes to our built environment. My name is Stephen Koenig. I'm an architect and an Alexandria Planning Commissioner. I'm joined today by my colleagues Scott Barstow and David Peabody. Our presenter is Timothy McDonald, an architect and developer whose work demonstrates that passive house and net zero together create excellent residential architecture, which is achievable in the affordable housing market. I have a few observations to set the context for Tim's presentation. In Alexandria, we are engaged in long-running, intertwined crises of affordability and the environment. We are trying to make a city in which everyone can afford to live where we work, play, and learn. We are simultaneously trying to evolve our built environment in order to cease contributing to the irreversible destabilization of our climate. These efforts to strengthen and expand equity and to build responsible architecture intersect in the realm of housing. We have substantial assets as we continue this work. We are a community with informed residents, dedicated political leaders, and extensive resources. We have good plans and skillful multidisciplinary city staff to implement them. We have a capable and forward-thinking Office of Housing. We have an energized public housing authority, which is embarking on an ambitious redevelopment program. And we have experienced nonprofit housing developers with strong track records who have significant projects in the pipeline. We know that our buildings produce over half of our greenhouse gases, and we know that it is absolutely critical to cut these emissions by 50% in the next 8 years. Passive house and net zero are powerful tools which will help us do that, and they're available right now. Passive house design creates healthy, comfortable, and quiet living environments, which require very little energy to operate. Net zero energy is an approach which fulfills this minimized power demand completely from renewable sources. Together, these proven technologies create durable and resilient homes for their residents. These structures provide substantial cost savings over their entire lifespan and are buildable at current market rates. Our presenter today, Timothy McDonald, is president and CEO of the Philadelphia-based design build firm Onion Flats. He is a dedicated proponent of high quality, high performance affordable housing, who has helped incorporate credit for passive house certification into the low income housing tax credit process in Pennsylvania and in a dozen states beyond. Tim and his team have been developing, designing, and building certified passive house projects since 2012. As we proceed through the presentation, everyone please put your questions in the chat. We're looking forward to the conversation with you after the slides, and it's all yours, Tim.
Great, thanks, Stephen. Let me just share my screen here. Sorry, I can't seem to, there it is. Well, thanks for the invitation, Stephen and David and Scott. I'm happy to share our work with you. And I think what I'll do is share some of our own projects and tell you why we do it and how we do it cost effectively, but then also how those projects have informed a maybe even more important initiative that we're trying to get going across the nation around affordable housing and housing in general. But just to begin, I'm a big proponent of vertical integration when it comes to developing real estate. We're a developer, we're also architects, and we're builders. And we do that only for our own projects, but we also have a robust architecture firm where we're working for lots of multifamily, affordable and market rate housing clients. One of the other companies that's been created out of this desire to build high performance sustainable buildings is our green roof and solar company. So that's kind of a separate company that does client work as well as all of our own solar and green roofs. These are some of the projects that we're either in the middle of, have completed, or have gone through schematic design and the projects are on hold. But it's everything from a whole retrofit series of projects that we're doing in Massachusetts to single family homes, high performance single family homes, to these larger scale multifamily projects in Philadelphia, but really all over the country. Here are some other ones in Baltimore. We're doing another retrofit net zero energy passive house project in Louisville, Kentucky. So I'm just trying to give you a sense of the scale and scope of the nature of our work. But what really grounds me every day when I wake up is the knowledge that buildings in this country are responsible for almost half of all greenhouse gas emissions. And I don't say that lightly. I think that needs to sink into everybody's brains here, particularly if you're an architect or if you're in the world of building buildings, the built environment. We're half the issue. In Alexandria, it's even more than that. Between commercial and residential buildings, they're responsible for over half of all greenhouse gas emissions. Now, if we think we have any chance of addressing the climate crisis that Stephen mentioned, we've got to do it with buildings, and we've got to do it immediately. Why do I say that? Because even though your environmental action plan of 2040 states what pretty much every climate action plan I've seen in any city, any state, or frankly any country, they're using the 2050 target of the Paris Climate Agreement for carbon neutrality. All carbon emitted needs to go to zero, a very different world by 2050. The problem is that that's actually too late. If we peaked emissions in 2020 and just a straight line down to 2050, just the area below that triangle accounts for about 600 gigatons of CO2 that we would be emitting. Number one, we didn't peak emissions in 2020. Number two, we only have about half that left to emit. So it's actually got to be much more radical than that. We've got to radically reduce our energy consumption, as Stephen said, in the next 8 years, 65%, not 50%, in order to emit no more than the 340 gigatons of CO2 left to emit. If, of course, we want to keep the globe from warming more than 1.5 degrees centigrade, and we don't need to go into what that means in this presentation. So for me, as an architect and a developer, that means that carbon neutral net zero energy buildings need to be standard practice, code by 2040. What that means for me is that building needs to generate what it needs on its own site. In other words, people think you can buy carbon offsets in order to pay for the carbon that your building is emitting. We're never going to get there if we treat this as a carbon offset strategy. We've got to generate what the building needs on its own site. Okay, so can we do that? Well, here's a typical row house on the East Coast. This is about how much energy that building uses in a year, 39,000 kWh per year. And here's the size of the roof, 16 by 40. Could this building get to net zero energy? It could, but it would need a roof 5 times bigger than it has. And so we've got to reduce the consumption to what the roof can produce, right? So that's about 80% reduction in energy consumption. We all know that heating and cooling of buildings is responsible for more than half of all energy consumed in the building. So my question is, what's the best heating and cooling system, most efficient, most cost-effective heating and cooling system out there? I think it's a coat. And that is the essence of what Passive House is really about. It's a fabric first. You're focusing on the fabric of the building first. And in so doing, by building a super insulated and really, really airtight building, you can reduce the energy consumption by up to 80% within that building. And it boils down to just simply good building science. Continuous insulation on the outside of the building, thermal bridge-free construction. You know, if you can make a simple compact shape, it's got to be an airtight building. But when you make the building airtight, you then have to give it a lung to breathe. So you have to bring in fresh air and you have to exhaust stale air continuously. And then just obviously, you know, optimal solar orientation, energy efficient appliances, and so forth. So here are a couple of projects that we've completed over the past 10 years, 10 or 15 years. This is a 26-unit townhome development in the Northern Liberty section of Philadelphia called Stable Flats. We completed in 2015. When you can orient your building to the south, it's difficult to do sometimes in urban environments, we do so. And so that's what we did. We aligned these three banks of housing, blocks of housing to face south so that we can manage the sun in the summer and bring it in the winter, generate power from the roof. But we can't just think about how we get there by thinking about how we design buildings. It's really about also how we build them, because we are effectively building our buildings the same way we've been doing for the past 150 years. And we've got to start thinking much more efficiently and effectively about how we build buildings. And so in this case, we started a modular factory. Actually, we partnered with another company in order to specifically develop a modular building system that could be replicated and simplified and meet the Passive House standard. And so the first three of these houses, we, as an experiment, I had many partners on this project. So they agreed to do the first three through this modular factory. And so as you can see, the plumbing and electric and finishes are all in place as we're delivering the project. The first three were built with about a 4.5 kW array, PV array on the roof. The rest of the houses were built by different companies, different partners had different relationships, but all built to the same Passive House standard. Big fan of really thinking about the importance of a roof, especially in an urban environment, because a roof has to do so much. It has to manage stormwater. It has to generate the power that a building needs. It has to, you know, open space is a commodity. So it has to be amenity spaces, green spaces, and so forth. So the green roof below this solar array actually keeps the temperature lower on the roof, and so it makes the PV panels that much more efficient. And when you build a Passive House building, you've got to make it tight. You've got to make it as tight as you can do, and as you can. And as I mentioned, then you've got to bring fresh air into the building, and you've got to vent it properly. And so the first thing that you have to do once you build it is to measure just how tight it is. And 0.49 ACH50 essentially means that if you take the volume of the building, cut it in half, 0.5, that volume, half the volume of this building can leak out within an hour. That is super, super tight. Do you know what a typical building would be? It would be 7 ACH50. 7 times the volume of typical code-built buildings leak out within an hour under a certain pressure. And so a Passive House is essentially, you know, 14 times more airtight than a typical code building. And I must emphasize, airtightness is actually more important than insulation. And airtightness doesn't have to cost a lot of money. It's really just about attention to detail. And at $150 a square foot, this was built at code-built construction costs. And part of this had to do with the decision to prefabricate. Part of this had to do with the vertical integration. Part of it had to do with carefully designing mechanical systems that were cost effective. But in the end, these 2,500 square foot townhouses are using about $90 a month in utilities. Now they could put another 4.5 kW array on the roof and get to zero if they wanted. Right around the corner from this is a much larger project, and it's a project that is part of an 18-year development. The first development was a retrofit of an existing factory. The second was the first LEED platinum duplexes in the country, and then we came back about 8 years later and developed the largest passive house project that we'd taken on, called the Battery. And it's a 25-unit apartment building, about 17,000 square feet, all centralized systems, which I'll mention briefly and we can talk about later. And we're tending to move away from these centralized systems now, but you can get a sense of the R values in the walls and the roofs. This is pretty typical for passive house within our climate. R34 walls, it's about not so much twice what code is. No, it's about twice what code is, but the roof 54, not too crazy, really good windows. And at the ground level, we needed parking, just like most people do. So half of the ground floor is parking, half is lobby and a couple of units. Very simple organization of mostly one bedroom, couple of 2-bedroom units, about 500 square foot apartments, double loaded corridor. And as I mentioned, prefabrication is a key to cost control for us. And in this case, instead of modular, we said, you know, the most challenging part of a passive house building is the envelope, that fabric, that first fabric, because that's where it's got to be really well detailed. And so we're big fans of not trying to reinvent the wheel, not trying to train an entire industry. So we actually had our envelope show up complete with triple pane windows and doors already installed, the weather resistant barrier, the air barrier, exterior insulation already installed. And this building went up in half the time. It cost me half the amount from the framers because they didn't have to install windows. They didn't have to put on all these layers. They just had to put these pieces together. And again, airtight building, you've got to give it a lung to breathe. We've got 2 centralized ERVs on the roof, energy recovery ventilators that exhaust all the air 24/7 at a very low volume, and then supply air all at the same time without losing any energy. Here's that kind of pulmonary system of supply and exhaust in the building. You're supplying each bedroom, each living room, you're exhausting each kitchen and each bathroom. And it needs to be balanced. Whatever you're bringing in, you've got to bring out. And the other beautiful thing about balanced ventilation is that it's triple filtered. And so the indoor air quality and the health of the occupants is superior to none in a passive house building. In this case, we drilled 2,000-foot deep geothermal wells into the ground. Why? Because it does our heating, our cooling, and our domestic hot water all in one. And here's how that kind of merges with the ventilation system here. This is what heats and cools the entire apartment, just this one wall-mounted unit. So no condensers on the roof, for instance. And then I want to really make the point of the importance of electrification. What do I mean by that? I mean, buildings don't need gas. They simply don't need it. We haven't put gas in a building in 15 years. So that's number one. Number two, it's significantly more cost effective to only bring one utility into a building. You bring gas in, you've got to vent it every time there's combustion. There's significant cost with bringing gas into the building, and you don't need it. You don't need it for hot water. You don't need it for laundry. You don't need it for cooking. And so electrify and simplify. Now, the next thing that we tested was, if we're building these 500 square foot apartments, the utilities for them are going to be about $20 a month. Why would we have an entire room filled with 25 meters just so that they can pay this minimal charge each month? So we decided to bring 1 meter in, master meter, and 1 meter out for the solar. We're monitoring the energy consumption of the units anyway, so why meter at the same time? So we're charging tenants a $50 flat rate, and we're actually making money. They're really happy because $50 a month is about half what they would pay in a typical building. So it seems to all work. Again, blower door test becomes a really critical part of the construction process. Everybody's excited when we hit the blower door test, and we did so here. And here's the building as it's completed. I'll just note that this is a west-facing wall, so all of what you're seeing here has a couple of functions. One, it's shading the windows, but these white panels have LED lights above them, and they're tied into the energy monitoring system of the building. They're also tied, they have an AP address associated with them, so they're also tied into each apartment, but nobody knows which apartment is tied into which light. And so it's a bit of a who's who. If you're, when you come home at night, if you're working within your energy budget, your light will glow green. If you're really far out from it, it'll glow red or yellow, somewhere in between. And so this is a way to incentivize the community living here to kind of live within their energy means, but it's also a way to educate the larger neighborhood. Certified passive house project, and we built it at $169 a square foot, all in hard costs, all hard cost construction. And at the time, that was right in line with everyday code construction all around us. Here are some images from the back and the parking. This is the front entrance. You see a bit more of that shading and those white panels. Again, integrate solar. Don't think about solar as this thing that you can do later. Integrate it into the entire design of the project, because you really do need the entirety of your roof on these buildings, on buildings 4 or 5 stories tall. You've got to generate as much power as possible. So in this case, we lifted it 10 feet above the green roof, above the ERVs. And it also becomes this wonderful amenity space in the hot, humid summers of Philadelphia. Interiors are very simple, clean, but we use really good quality materials. We have translucent glass between rooms so that the space feels more connected and open. As I mentioned, we're monitoring the energy consumption of the building besides the 1 meter. And this is just the result of 2020's energy consumption. A typical EUI, and an EUI is the energy use intensity. It's kind of like the miles per gallon of a car. A typical EUI is 60 for a multifamily affordable housing project in Philadelphia. Our EUI on this project was 10, which is 83% better than code. So we're proving what Passive House says we should be able to do. One of the last projects I'll show you is a project we just completed a couple of years ago called Front Flats. It's about 5 minutes north of this in Kensington. And one of the 2 of the big things that changed here, the experiments that we took on, was we started to think about solar in a different way, not just as a power generation, but as a skin. And I'll talk about that a little bit more. But we also reconsidered the way the mechanical systems work. We became much more interested in decentralized strategies, which I'll show you in a minute. And at $180 a square foot, again, in line with everyday code construction. Here it is from above. It looks pretty opaque, but really the integration of the solar into this building is a very different take than the last one, because we're floating these translucent panels. You can see the light coming through the panels. We're floating them about 24 inches away from the facade of the building. And the reason for that is threefold. We call it our solar veil. It does three things. It certainly generates all the power that the building needs, but this all important summertime shading is one of the most crucial parts of this facade. You've got to keep the direct heat of the summer out, but then let it in the wintertime when the sun is lower in the sky. So that's the other. It's a shading device, but it's also a visual privacy device. It's on a very tight urban site. And so instead of having, you know, blinds or curtains, it actually blocks anybody from seeing into your apartment. And once again, this is what roofs need to start looking like in our urban environments. They need to be able to grow. My tenants are growing tomatoes and basil over here. They need to manage stormwater. They need to generate what the building means and become a wonderful amenity space. And these were our modeled projections. This is what we projected we'd consume and produce. And it was pretty much dead on what happened. We were only going for enough solar to make the residential portion net zero because we weren't quite sure what was going to happen in the commercial. And we generated 26,000 kWh more than we needed. And so we just put that into the commercial space. And so it's a net positive energy building. But the other interesting thing here is that this metric of most developers want to put the utilities on the tenants, and I totally understand why. But again, the second you start building these super energy efficient units, maybe it's time to rethink the utility issue, because utilities can then become a revenue stream for the developer if it's a master meter. And that's exactly what happened in 2021. We made an additional $16,000 a year of additional revenue just from the utilities. Again, prefabrication key. And again, single meter. In this case, we're only charging tenants $40 a month. We could ratchet that up. If we made it $60 a month, it would be even that much more financially viable for the developer, and the tenants wouldn't complain in the least because again, that's half what they would pay somewhere else. We're also exploring and more interested in decentralized heating, cooling, and ventilation strategies. You can ask me about that later, but there are now new products coming out that merge all of those systems into one unit, an ERV and heating, cooling, and dehumidification unit, where the condenser is actually built into the unit. So it's called a packaged unit. So you're not running line sets and refrigeration lines to the roof. You're not filling your roof with condensers. The roofs are clean, free, and everything is contained in this unit. You've got a supply and an exhaust going to the outside, and then very simple ducting to each room in the building. And here's how it fits into, these are 450 square foot apartments. So it fits nicely into kind of the cabinetry. We built these drawers even for more storage underneath, but it fits nicely into the cabinetry. And even in a 320 square foot studio space, this is a Murphy bed that pulls down, but it works. Here's the heating and cooling system. And then one of the last things, I'll just quickly go through this, but hot water, once you solve the heating and cooling issue, reducing your consumption significantly, hot water is the next energy consumer to take on. And so this was our initial strategy, a centralized strategy where we have essentially a power plant on the roof with condensers and a centralized system, so that there's this very long loop of supply lines going to all the fixtures. And then this blue line is what's called the recirc loop. And that's there to allow somebody that's very far away from the plant to open up their faucet and not wait for 5 minutes for hot water, but wait for 3 seconds. That loop has hot water running through it, being pumped through it 24/7. And so I hated the idea of this extra loop of piping and heat loss and energy consumption. And so we redesigned the strategy for the hot water system in this project by looking at the way venting works in the building. And the premise of plumbing, venting, and sewage is that your vent stack runs up right very close to all your fixtures. So you've got very short horizontal runs to your fixtures. And so for a different reason, for energy conservation, we said, let's follow the vent stack with our supply water lines. And so we located off-the-shelf heat pump water heaters at the bottom of these stacks, ran up very short vertical and very short horizontal runs so that we cut the piping in half. We cut the cost of the heat pump system in half. We cut the insulation in half as well. So this is a significantly more cost-effective approach to making hot water, as well as energy, significant reduction in energy consumption. But then the last part of this, the recirc loop, there's a technology out there that allows your recirc loop to go inside your supply line, such that you're only insulating one pipe, not two. You're not insulating the supply and the recirc, but the recirc pipe goes inside the supply line and you insulate one pipe. So again, we cut the heat loss and energy consumption in half again. And here are those typical hot water tanks. And then the last project I'll show you is Belfield Townhomes. It was our first passive house project. It was for affordable housing, formerly homeless families, large families, 5-bedroom units. And it was the first certified passive house project in Pennsylvania. It was also our first attempt at a modular project. And this is where we really kind of cut our teeth on developing a simple prefabricated strategy for building these high performance buildings. At our first attempt at a blower door, a passive house blower door test, and we beat it by 30%. I'm not trying to pat myself on the back. I'm just trying to say it's not that difficult. And this is what it means to build a building that doesn't leak heat out in the wintertime. This was taken in February. You can see what the rest of the neighborhood is like. It's just pouring heat out of the walls. Here you're keeping it in. Simple but beautiful, resilient materials, lots of light, lots of air, triple pane windows. At the time, we could only get them from Europe. Now we can easily get them from multiple manufacturers here. And with 5 kW on the roof, it was designed to meet all of the energy consumption of the building. And at $129 a square foot, we said, well, if we can do this at our first attempt at a passive house project, why can't others? And so we went to the Pennsylvania Housing Finance Agency and we said, look, we showed them the project and we said, why don't you just push the idea of net zero energy capable buildings as standard by 2030? Maybe they don't put the solar on the roof, but they design it as a passive house building. And they said yes. The goal is net zero carbon neutrality, but the best tool I've found is passive house, and they agreed. They said, okay, well, how do we do this? How do we incentivize developers to build to this standard? And that's when I learned about the low-income housing tax credit program and the QAP application process. And as you all know, in every state it's slightly different, but Pennsylvania was 120 points. The more points you get, the more opportunity you have to get funded. It's extremely competitive in every state that I've talked to. And so they suggested, let's just put an extra 10 optional points in here for passive house, see what happens. Well, what happened was 38% of the projects that applied, there were about 100 projects, 38% of them came in as passive house projects. Why? Not because they wanted necessarily to do the passive house projects, but because they wanted the 10 points. They wanted to get funded. So that competitive nature of the QAP actually is the secret sauce in getting these projects to make sense. Now, the question is, PHFA funded 7 multifamily projects here. Well, how did they look in terms of cost effectiveness? Well, these are the cost per square foot, the hard costs of all those projects that applied. All the white ones are code built applications. All the orange and yellow are the Passive House projects. Well, we compared the code built to the Passive House projects, and it turned out that it costs 2.5% more for the Passive House projects than the code built projects. PHFA said, you can do that within your contingency. This is fantastic. And they said, let's do it, let's go. And so they funded these 7 projects, they all got built. The question was, did they get built for what they said that they would build them for at application? Well, turns out, yes, they did. These are people that, these are developers that have not done Passive House before. And yet, at application, they were $161 a square foot on average, and they got built for $168 a square foot within their contingency. Same exact thing for the non-Passive House projects. They cost a little bit more at completion, but within their contingency. And so the point is, they got built with inexperienced builders, architects, and developers for the cost that they said that they would build them for. Oops. Second year, they funded 10 projects. And we did the same comparison again. And guess what happened? It flipped. The Passive House projects came in about 2% less. And again, I don't care about whether it's 2% more or less. I think the point here is that these high performance projects, these buildings that are using 75 to 80% less energy than typical code buildings, are being built on par with code buildings. And here are all those projects that were funded and are now built. The second and third, or the third and fourth year, 8 more projects. Exactly the same thing happened. Exactly the same difference, delta, between the non-Passive House projects and the Passive House projects, on par with code built construction. And this is one of those that initially got funded. And I just want to make one point here. This is for veteran housing, I think 49 units. It was an existing historic building actually right here. And they built a 49 unit apartment building around that. Prefabrication. The foundation itself was this prefabricated insulated panel. So you're not building a stem, you're not digging a footing, pouring the footing, then building a stem wall, then pouring the slab. This is all in one. The insulation for the foundation itself, all in one. So it took half the time to pour this. And on top of that prefabricated foundation is a prefabricated wall system, like I've showed you in other projects. The wall showed up with the insulation in it, exterior insulation, windows, doors, went up in half the time with a team that has never attempted a Passive House project. And before the drywall and insulation was even up, pre-blower door test, pre-drywall blower door test, we hit the Passive House standard. And then the final one was even better. So this is the point I want to make for all the developers out there, as well as the housing finance agencies. This is a typical allowance for a 1-bedroom apartment in terms of utilities. Well, the owner went back and said, well, look, and this was conservative. He said, look, we're going to be able to cut that in half. So I should be able to generate more revenue, right? Because as you all know, 30% of somebody's income goes towards rent and utilities. Well, what happens when the utilities come down? The rent should go up, so the revenue should increase. And that was the argument he made. And he said, I should be able to pull more money out of this project. And that's exactly what he did. He pulled $300,000 in further debt out of the building. And I just love what he says here. Passive House lets you borrow, leverage more money to build more housing. So this isn't just solving the climate crisis. This is solving an affordable housing crisis, not to mention an equity crisis and a health crisis as well, because these are the healthiest buildings you can live in. And there it is. He put $300,000 not in his pocket, but into more housing. And so there it is, completed. And the last thing I just want to say is we just said, this didn't take much. We got a paragraph put into the QAP. Why not see what other housing finance agencies would do? And so we went to date, 40 housing finance agencies. We're just not through all of them yet. And so far, 18 states, and I just found out that Virginia is one of them, have done something similar to what Pennsylvania did, put Passive House into their QAP. Now for Virginia's, this is kind of I've never seen this before, this idea of 10 future points. But as far as I'm concerned, if Passive House is built into the QAP, they're going to get built if they're incentivized to do so. But you really have to provide more points for Passive House. You can't kind of align them with any other green standard. And it's happening. It's happening in all these states. All these housing projects are being built to the Passive House standard. Here's a perfect example of what happens when you put Passive House in and make the points equivalent to LEED. No Passive House projects get built. Here's what happens when you give more points to Passive House projects. Now remember, LEED isn't necessarily entirely or enterprise green communities. It's not entirely focused on energy consumption. Passive House is about radical reduction in energy consumption. So you should be getting more points for those kinds of projects. And even in 14 other states where it's not in their QAP yet, they're still building them to the Passive House standard because it makes sense. And here are some examples of that. We have a conference every year that is focused specifically on affordable housing and Passive House buildings and lessons learned, called the New Gravity Conference. There'll be one this summer. I hope you can make it. And the last thing I want to say is this initiative is laser focused on affordable housing because of the competitive nature of the QAP. But the intent here is that the architects, engineers, and builders that do affordable housing very often also do market rate housing. And so this initiative, while focused on affordable housing, is really a catalyst for market transformation, because we should be doing this in every industry, part of the building industry. And so just the lessons learned to take away here is, again, prefabrication, vertical integration, keep it really simple, educate your tenants about the systems and utilities, leverage those utilities to build more housing, incentivize Passive House beyond some of the more holistic sustainability programs. Please don't put gas in any buildings. You don't need to, and you'll save money doing so. And don't think about PV as second or later. Think of it as part of your capital stack now. And work on policy rather than pilot projects. Don't fund one project at a time just to see how difficult or expensive it would be. Do what PHFA did. Fund as many as you can and make developers understand that this is the direction that we've got to go in the next 10 years. So I may have gone over my time, but thank you. Open to questions.
Thank you, Tim. That's really marvelous. It's fabulous work, and it's an incredible density of information for us to work from. A couple of quick comments, and then I'll have one question just to start off, and then I'll pass it on to David and Scott and the attendees' questions. First, of all the lessons that you mentioned there at the very end, I was also taken by, from our point of view, in terms of trying to get this, to get some traction and actually start building this way in our community. Your point about policy over pilots was really helpful, because we've been looking, for those of us kind of working on this, just everything that's possible. And I think the fact that policy in the end, once you get it adjusted, generates a flow of work relative to pilots, where we're just saying, we can't get anybody to do this, so can we go get a little blob of money and tack something on this one project and then turn around and point at it and prove that it's the right thing.
Right.
It works, but it's so much slower and so much more difficult. It may still be a good tool sometime, but I think your focus on policy is one we're trying to act on. Also, your work there to expand the sort of way that the tax credit competition works across the country is hugely valuable work. And as you mentioned, it has had an impact in Virginia. And as we had discussed offline beforehand, your observation about passive house credit, that's actually been in our QAP for at least a year or two now. I still don't understand what the futureness really means, but that's the way it is. But in addition, as of January 2022, our low-income housing tax credit competition criteria include points for renewable energy on site, up to 2 points, up to a point per 2% of on-site load managed, up to a maximum of 10. So there are another 10 available now specific to the on-site renewable system, which I'm hoping will help as well. So with all that being said, I did have a question for you. The Alexandria Redevelopment and Housing Authority, which is our public housing agency known as ARHA. ARHA is now in concept design for a redevelopment project for a 2-block site, downtown, height limit about 100 feet max, about 150 units altogether, 2 buildings, 1 on each block, 1 tax credit financed, 1 conventionally financed. That's sort of the situation. And they have committed to pursuing net zero with an understanding right now that they can do it on the tax credit building, but not the other. I don't know exactly why. But if that's the setup, what kind of observations and challenges could you identify for us in how they could get that project to a complete passive house, full net zero, integrated project in the end? And again, we're about to see the very first concept study for them.
Yeah. Well, the first thing is it absolutely has to be built to call it passive house, call it whatever you want, but an EUI of 20 or below, right? In the 20s or below. And that's without solar. So you've got to reduce it by, you've got to reduce the amount of energy that the building would consume by 75 to 80%, period. That's the most important thing you can do. But the second most important thing is you've got to really think about this roof. As you can tell, roofs are really important in our projects, and there's a reason for it. If I had my roof filled with 150 condensers, where would my solar go? So how you've got to think holistically about what this roof needs to do. If you're truly interested in net zero energy consumption, you've got to pack the roof with solar. And that might not be enough depending on the height of the building. Obviously, if you've got a tower, the roof isn't going to do all of the energy production for a 20-story tower, right? We found that it's 4- and 5-story buildings, your roof should get you pretty darn close to that net zero energy number, but it's got to cover it completely. You can't just fill it in between condensers and ERVs and elevator cores and so forth. So it's a whole, and so therefore, notice I don't have any condensers on my roof because I choose mechanical equipment that doesn't need them, that either has them through geothermal or they're built into the unit themselves.
Thanks, Tim. That's great. That's all incredibly focused and indicative of how the pieces, how critical the fundamental pieces are and how they have to fit together. And I think one of the things that's, of the many things in your presentation that I think would hopefully be very informative to the developers and the designers that we've invited to this, or hope we'll see it at some point, is this question of how you manage an integrated design of the roof and how we get all that extraneous gear off of it. And so I think something that we hear all the time in the multifamily world is how challenging these heating and cooling and domestic hot water situations are. And you've shown us a series of ways that you've gotten that more efficient, more integrated, and in a way that is saving money and is more durable and is also opening up the roof for an integrated human space, stormwater, energy production integration, instead of a place where we have a lot of mechanical equipment looking at the sky. So thanks a lot, Tim. I'll step away and pass it on to David or Scott and what's coming in through the attendees in the way of questions.
Sure.
Tim, that was a great presentation. Am I muted or am I on here?
You're on.
Good. There were a couple of questions that came up in the Q&A about size, both height and bulk of buildings. And maybe you can address that question of how high, how big a building will the passive approach work on? And, what are the limits there? And maybe talk a little bit about why it's more efficient actually to build larger buildings that are passive.
Yeah. So it makes sense to build any size building with passive house. I mean, I'm sure you guys know of Jonathan Rose. He's one of the best affordable market rate developers in the country. He is building, I think it's completed now, a 650 unit passive house project in New York City. He's about to build one in Philadelphia. It's going to be a tower. It's again, passive house. The larger the building, actually, the easier it is to hit the passive house standard. And I know that sounds weird, but think about it this way. If you've got a tiny house in the middle of a forest somewhere, you've got 6 sides with a very tiny volume, right? So the volume to surface area is out of whack. What that ends up meaning is that your walls get really thick. So the larger the building, the thinner the walls get. What does that mean? That means the more cost effective it is. The lower the R values. I know some large projects that in New York City that found a way to make double pane windows rather than triple pane windows work. So in other words, the point is the larger the building, the more cost effective it is to build to the passive house standard. I'm not sure if that answered all of those questions, but let me know if I missed something.
No, I think that's a good answer. I think the surface volume ratio is the key thing here.
Yeah.
And also in Alexandria, most of our buildings exist, and that's the biggest part of our problem here.
Yeah.
And there are a couple of good questions about that. One is, one person writes, for a 12+ story, 50-year-old building, that might be cost prohibitive for resident or investor owners. So could you address a little bit your experiences with retrofitting and strategies that you've used?
Yeah, so I'm trying to make it brief because it's a bit of a long story, but I'll just put this out there. Google Rocky Mountain Institute Realize program. The Rocky Mountain Institute, if you don't know about it, you should look it up because it's been around for 30, 40 years. And it's all about energy. It's an organization all about energy efficiency. They started a project, an initiative called the Realize program, which is based on an initiative that was started 20, 30 years ago in the Netherlands called Energy Sprong. And the premise of both of these initiatives is we've got thousands and thousands of these 12-story buildings that were built in the 50s and 60s that are just horrible single pane windows. And what do you do with those? The biggest issue is moving people out in order to retrofit them. So in the Netherlands, they developed what's called an exterior retrofit strategy, where they designed these high performance panels, these envelopes that you essentially click on the outside of the building. And inside those panels are high performance mechanical systems. It's really beautiful. You've got to check it out yourself. But the intention is to make it a high performance building while people are still living inside the building. And so you put the envelope, this high performance envelope, panelize it on the outside, and then you come in one day to swap out the old window for the new and tie it back in. Realize is trying to do the exact same thing in the United States. So is New York Retrofit. You should check that out. But they're focused on these exterior panelized retrofit strategies. And the intent is to get they're in Massachusetts, they have what's called a 1,000 apartment challenge right now. In the next 2 years, they're going to have 1,000 units under construction in this retrofit strategy. And we're working with them on that. We're actually designing the strategies to do that. We're just at the point where we're trying to see how cost effective it is to do this. And so in the next 6 months, I'll be able to tell you more about that. But of course, the intention is just like in the Netherlands, it started out being really cost prohibitive. And then it was cut in half. The cost was cut in half within about 5 years because of the demand. And so that's the intent. The intent is to get this off the ground because half of our issue is existing buildings, and we've got to take them on at the same time.
Great. Scott, do you want to jump in here with some questions?
No, go ahead.
Okay.
I see someone posted one that Stephen might want to address, though.
We've got 2 lists of questions here. But one is that's addressed to Stephen is, can we get ahead of the curve with this Hilco, the developer on the power plant site? Their site is to be an innovation zone. This would be a major demonstration of that commitment.
Thanks. Yes, and I'm sorry, I was looking at the Q&A and I lost track of the chat there. Yeah, the Potomac River Generating Station Plan, the questioner's exactly right. I mean, it's going to be another one of these issues where we're creating a half a dozen new city blocks over the next 20 years out of this to be reclaimed industrial site. And as the questioner may be aware, that is in concept stage now, and Hilco, the developer, has made a series of presentations to the community. The most recent one was just last week, and I'm sure it's up on their website now, that address both remediation and sustainability issues on the site. The applicant they have put together a draft carbon neutrality analysis, which is something that some of us on the Planning Commission and the Environmental Policy Commission have been working with staff and the applicant since early last year to try to get a mutually agreed way to approach a site like this from the beginning as a high performance energy district. One of the things we've been pressing is that the National Renewable Energy Lab master planning guide for high performance districts is a excellent blueprint for exactly this kind of transformation that addresses the question of thinking about a multiple block site like this as a fully integrated site, not just a series of kind of inadvertently adjacent disconnected buildings, so that district energy and grid integrated buildings and microgrids and all these opportunities we have to become efficient at the scale of a multi-block site, and then to proceed through the kinds of things that we're seeing in Tim's work of individual projects brought to a level of efficiency. That's a long way of saying all of those things are, from my point of view, necessary and available. And we are in the process as a community and as a developer now trying to see whether we can actually begin to realize net zero energy, truly carbon neutral in the near future, redevelopments of sites that are going to bring another couple million square feet to the city, and all of the good things that are entailed with that, and finding a way to do it so that we are not exacerbating the climate emergency that we're deep in the middle of.
Tim, there's one question came up early on about gas, and about having a gas on the site, and one person asked about justifying natural gas when you need generators for hospitals. Like let's say a hospital absolutely needs backup power.
Yeah, I get that.
About batteries. Are batteries in play for even that?
Yes, and you know, I mean, we're not quite there yet with battery technology, but certainly with in the next 5 years we will be. But yeah, that's pretty much, you know, you can't say no to gas with every single solitary building type. A hospital is a good example of where, you know, if I were doing that, I would probably bring gas just for that backup generator. But before I made that decision, you know, every year that goes by, we've got more and more capacity for these kind of commercial large-scale batteries. And I would just want to see what the state of the technology is at that moment. Because I think within the next 5 years, that's going to be a no-brainer.
Yeah, actually, David, if I could, just to piggyback on that one, because it also plugs back to the Hilco site. I think, the hospitals are probably the hardest nut to crack on emergency, and we saw that on our landmark project with Innova's new building. But back in terms of Hilco, if we look at a site like that, that's going to have, multiple hundreds, if not more than 1,000 cars vehicles built into underground parking there. One of the things that our transportation sector is making major progress on in electrification of vehicles is not just the efficiency and the utilization of the vehicles themselves, but then they become this gigantic hive battery source where you can both shed load and gain power when you need it. And I was in a conversation the other day, I lose track of who it was with, but in reference to Hilco, that there are ways that on a site like that will be several million square feet on 6 blocks, but doesn't have a lab building, doesn't have a hospital building, that are mostly multifamily and conventional commercial. We might very well be able to sort of refrain from the fossil fuel infrastructure, even for those hard nuts like the generation, because I agree completely. And while I'm still talking, would like to reinforce as much as I possibly can what Tim said about fossil fuel is we just have to proceed with ways of building without putting these incredibly complex, expensive, fundamentally dangerous, and incredibly destructive from a climate point of view systems in place. And when we manage to refrain from doing that, we will be saving money and making safer and healthier buildings. And it's not going to be simple, because this piece of the building industry and our infrastructure and our society is still a powerful player in all these questions of finance and policy that we've been talking about. So I'll wrap that up, pass it back to you, David, and also note that we're 3 minutes past.
Yeah, we're near. One question that we see a lot in the city, and in any city, I think, is developers come to the planning commission, they come to council, and they say, we would like to do zero energy buildings or passive buildings, but we just can't do it because our builders aren't ready, our architects don't know how to do it, and because of that, it's going to cost us a lot more. And this guy, Tim McDonald, might be able to do it, but we don't have a Tim McDonald here. Let's address that. Maybe you can talk about that.
I mean, that is precisely. By the way, I spent a summer cold calling 40 other housing finance agencies. Just called them up, tried to find the right person in the housing finance agency to talk to about this, and every single one of them didn't know what passive house was. Every single one of them said it costs too much, even though they didn't know what it was. It has to cost too much. And so the whole point of my narrative to them was, here is evidence that it doesn't have to. And it's not just, but at this point, now that we've got years and years, hundreds of buildings being built and data that backs up that it doesn't have to cost more, what more do people want? Because you can imagine how difficult it would have been if we didn't have that one building that we built when we went to PHFA and we said, look, we demonstrated it that it can be done here. They use that to leverage the ability for other people to do it. They're doing it. It's not me. It's hundreds of developers that, frankly, most of them don't care. They're only doing it because of the competitive nature of the QAP. But the reality is, when they do it, would you go backwards? If you built a building as a developer that uses 75 to 80% less energy, and you built it at the same cost as you build a code-built building, would you go backwards on the next project that you did? I don't think so. So my answer to that question is, just look at I'll give you a 2-hour presentation And I'll go into individual buildings that other developers and architects and engineers and builders have built and the costs at which they've built them. So what it boils down to is you need the right team to do this, and you need to be committed. If you're not committed, then you're going to find all kinds of reasons why it could be more expensive. But my answer to how is it possible, when people say, how is it possible that those passive house buildings came in 2% less on average than the code built buildings? And I said, it's very simple. When people are forced to do something, they get creative, right? That's why I don't like pilots, because you're not forcing anybody into doing anything. You're saying this is an experiment, and because it's a pilot, it's necessarily experimental and it's necessarily more costly. Rather than do that, just say, here, just everybody do it. And then collectively, we'll come to understand, as we have in the past 5 years, that it's totally possible. You just have to have the right team.
Well put. And,
David,
yes.
David, can I jump back in just for a second? A couple of things. One is, Tim, if you could hang on for another minute or two.
Yeah.
I know we're past time,
No,
but
it's
I'm
good.
looking and we still have about 25 people on the
Yeah.
call, and we have another couple of questions.
Yeah.
So I wanted to make 2 points if I could. One is on the question you just answered, your point about the fact that once you get it into the requirements and it is a requirement, everybody has to work to that standard, that's a big push. But I'd also reinforce a point that you made earlier and have demonstrated in your work, is that it's not just that they're forced to do it, but that you have found ways that those of us who are architects with not hyper specialized skills and haven't done 1,000 buildings, a basic competent architecture and engineering capability can follow the lead that you've made, which is this is not exotic construction. It doesn't require us to wait 6 months to get titanium bits from somewhere on the other side of the world. And that's part of the equation that you've succeeded with as well. And I wanted to ask one more question, because I see that we have a question from Tamara Jovovic, who is one of our very engaged, highly capable Office of Housing staff members, and is deep in all of our projects in the city, and is also familiar with the test case that I had mentioned to you earlier, Tim, about this ARHA project that's on the front burner. And she asked about whether it's more difficult to implement passive house design requirements on larger projects, 100 units plus, that get into concrete and steel frames. Are there additional complexities, and I'm paraphrasing here a bit now, relative to the smaller buildings, or is it just as achievable to move into those building technologies at the kind of 6, 8, 10, 12 stories we were talking about before and still achieve passive house the way you've described?
Yeah. What I would do quite simply is to say, you really need to look at the New York passive house. New York City is the center of passive house development in this country. There are literally thousands of units being built currently to the passive house standard. Very large buildings. I mentioned one of them, Jonathan Rose's 650 unit project, but there are hundreds of projects planned. And my simple, I think I mentioned this earlier, but the larger the building, the easier it is to build to the passive house standard. Now, there are more considerations when you're building with steel and concrete, because you've got thermal bridge issues. But again, they've been answered. The technology is there. It's been developed. It's been tested. It's been built multiple times. So I would ask you to look at a couple of resources. One, the New York Passive House. Just Google New York Passive House. It's a passive house organization connected to the International Passive House Institute. Check out PHIUS, PHIUS, Passive House Institute US, and then also check out Passive House Accelerator, which is an amazing resource of projects. Every single week there are presentations of projects frankly around the world, but primarily focused in North America, Canada, and the US. And there are just hundreds of incredible projects that are presented really short intense 15-minute, half an hour presentations, you'll have all you need to not question whether this can be done for larger buildings. It makes more sense for larger buildings than it does for smaller ones. Yes, FIAS Passive House Accelerator.
And I would just add, and I think we probably do need to wrap up, but that this community, for developers, for architects, and for builders, I've never seen a more sharing community than the Passive House community. Everyone is, because this is so new, people are sharing what they're learning at conferences and in phone calls. And it's easy to get this information if you want to find it.
Yep. Well, look, the only thing I'll say is this. I think the first thing that anybody says to me when I bring this up in affordable housing circles is cost, which is why I focus so much on costs. So if you take anything away from this presentation, take this away. If cost isn't the issue, why wouldn't you? What other reason, aside from fear, haven't done it before, all of that? I get that. But if there is so much evidence out there that if you have the right team, you can build these buildings that use a quarter of what they consume at the same cost, why wouldn't you? And I'll leave it at that.
Great.
Well, thank you, Tim. Again, we appreciate your dedication of effort. We know that we are among many communities that you're continually talking to on a regular basis to spread the information that you've gained from all of your work. And we appreciate the time and the fact that we have a communication set up with you these days and can continue to learn from what you're doing. And I suppose, let everybody know, as I hope they do, that the slides and the recording will be posted on the buildourfuture.org website. And we hope folks who have enjoyed it and taken advantage of the information we've got, and will pass it on to everyone they think might find it of some utility. And again, thank you, Tim, and we'll sign off with that.
My pleasure. Good luck.
Great. Thank you very much.
See y'all.
Thank you, Tim.
See you.